I'm going to be demonstrating term project for Applied Networking spring semester. Um, and it is a data transfer project. So I've already built the projects with Control-Shift-B. So I'm going to open Terminal and run the executable for the server first on the left. We're going to use a port number. It's 1234. As you can see, we are connected to the client, and now we're just waiting for them to send a file. So we are going to run the executable for the client. The server IP address, since I'm running this by myself, I don't have a partner. I'm going to use the home address, which is 127.0.0.1, as opposed to my partner's address that I would type in there, which would be a little bit different. So the server port, as we typed in on the left, is 1234. First, I'm going to demonstrate what happens if you type in a file that doesn't exist. So there is not a file called hello.txt in this file. This is the test file. There is not a hello.txt. So I will run that, and as you can see, the file is not found, so the program quits. Okay, so now we're going to run the executable again. So the port number, let's go with 1414. Now we're waiting for the client. The IP address, again, is the home address. And the server port number, as we typed in, is 1414. And the name of the file that I would like to send is the test.jpg. As you can see, that sent really quickly, and the numbers match here at the end, so there is no data loss. And all the bytes are received, and the test is complete, then they both close. Okay, so now we're going to open this file. This is the original picture that I'm going to put here on the right. And this file that was written has the timestamp on it. We are going to open that and put it here on the left. As you can see, they are completely identical. There is no data loss. So that's fantastic. Okay, so now I'm just going to go ahead and kind of walk through my code a little bit. So on the server side, we just create some variables that we're going to need. Make the socket, prompt for a port number, carry out some basic setup, bind the socket to an IP address, and then wait for a connection. It is connected, and then we wait for a message from the user. So we get a message from the user here, and if the message or the input is equal to quit, then the program will exit and end. So I can go ahead and demonstrate that. We'll clear the screen on both sides. So run the executable for the server. We'll pick a new port, 8000. The IP address is 127.0.0.1. Port number we entered was 8000. And the file, we're just going to send quit. And as you can see, it just terminates right away. So that's what happens here. And if it is not quit, then it is going to be a file name, and we're going to send that file name back to the client and let them know that we got it all right. And then the client will respond and say, hey, like, okay, that's great. We're going to be ready to start data transfer. And so we're going to receive start exclamation point. And if that is gotten correctly, we'll check and see if they are equal to each other. And if they are equal to each other, we are ready for data transfer. So we will mark the time at the time of data transfer and get the current time of the time zone, and then add that to the beginning of this stamped file, and then concatenate the stamped file with the old file name. And that is the new name that we have right here. Alright, and then once we get that new name, then we will write or open a file stream and use the concatenated name and store it as a file. So then while the input is not quit, we will transfer bytes. So we'll get the file size and store it as in bytes. We'll make this loop right here is making sure we get all of the bytes. The current point of where the transfer is at, the current amount of bytes, and how many bytes are left to be transferred. After you do that, then you want to actually transfer the bytes from one variable to another, from the old file to the new file, or old variable to the new variable. That way it can be written to the file here in a second. So again, we check to see if the input is equal to quit, and if it is, then we'll close the file and leave. But if it is not, then we will write the new variable contents right here, 1 byte at a time for however many bytes are left, and we'll write that to the new file with the concatenated name. And then once we're done, we'll send the current point to the client, and the that way the client knows where we're at for transferring. That way the client and the server are always on the same byte transferring at the same time. Then we'll close the file, and all of the bytes were transferred successfully. And then we'll exit the program, close the socket, and then end. So that's the server code, and then the client code is very similar. So variables create the socket, prompts for the IP address to be able to connect to the server. So remotely, ideally, that is for connecting from one computer to another, or for me, I just did that on the local host home IP address. And then you get the port number, which is the socket that you want to connect to. And then the basic socket stuff, then you want to prompt for a file name, and then you store the file name. Then you open a file stream that is named the file name, and if the file already has something or does not have something in it, then the file name will not be equal to quit. and then it will be quit will be copied to a variable, and then that variable is sent to the server. That way the client and the server quit at the same time. So, but if the file stream is not null, i.e. it contains something, then a file will be found, and the file name will be sent to the server. The server will send back the file that says, hey, we got it, but we just want to make sure it's the same thing. Then the client will check and make sure it's the same thing and be like, yeah, the two files are the same. So the file is confirmed, which means we're ready to start data transfer. So then the client will send start, which is a keyword for the server, and that will let the server know that data is about to come to the server. Then we will open a file. That way we can send it to the server. We will look at the beginning of the we'll look at the end of the file. And my comments right there, I missed it. Look at the end of the file, and then look at the beginning of the file and know how many bytes are in this file to transfer. And so while the position of the byte is less than however many bytes are in the file, so there's still data to be transferred, then you will be continuing to write to that new file. And you'll send data to the server for it to copy. So this is a variable for the last location. That way, make sure that the server and the client are on the same position of the data to be transferred. And then you will read in however many bytes there are, one at a time, and transfer the data from one variable to another, just like we did in the server. And then we will send that new data to the server for it to be copied, and then the server will execute its code and then send back a location. That way, again, the client and the server are always on the same page and there's no data loss. And then we'll print off the check location and just make sure that they're the same. So here's where they're checking to be the same. If they're not the same, then you want to go back to or see if the pointer is at the beginning of the file. If it's not the beginning of the file, then we want the current pointer to be the last known pointer location of bytes being transferred. That way all of the data gets transferred, and else they're on the same page and they get the current position and keep going. So if the current position is at the end of the bytes or past the end of the bytes, so there is no more data to transfer, it's the end of the file, then the client will send to the server quit to terminate the program. It'll close the file because data is done being transferred and the sending was completed, and then the socket will close and the program will end.